hopefully with sound. We're on a new packet. The new packet is Unit 3, Topic 1, Part 1, Special Angles and Reciprocal Trigonometry. A lot of the beginning of this packet is review from last year, and most of today's lesson will be that. Today we'll introduce three new trig functions you already know: cosine, sine, and tangent. We're going to add their reciprocal functions known as secant, cosecant, and cotan. And we're going to use the cosine, sine, and tan, as well as these three new trig ratios to solve problems. We're also going to talk about special triangles that you should memorize that are going to help us answer trig problems without using our calculator. They're giving us pi over 3, pi over 4, pi over 6, because these are measures in radians, so we'll review how to convert from radians to degrees and degrees to radians. And the reason we're doing those in radians is because those are real values, where it says where x is any real number. Degrees is not really considered a real number, but radian measurements of angles are. So later on, starting tomorrow, we will do the unit circle. But today, when it's talking about expressing values of sine, cosine, and tangent, remember, values are the same as ratios. Anytime I'm talking about sine, cosine, and tangent, it's just like where log is asking you what the exponent is. Sine, cosine, and tangent is asking what is the ratio of the triangle sides. And then they're talking about pi minus x to talk about the second quadrant, pi plus x to talk about the third quadrant, and 2 pi minus x to talk about the fourth quadrant. So let's start with our lesson. This was a page that you were supposed to do after your test, I believe on Friday. And I'll expose all of the answers, but for right now, I'm going to just talk about the first three problems and three of the special triangles that you should memorize. So for number 9, that triangle is going to look like this. It's always a right triangle, at least in this packet. Later on in trig, we will do triangles that are not right triangles. And it's already telling us that sine, so I'm standing here, sine of the angle, the ratio is 4 over 5. One of the things you need for this is SOHCAHTOA. And a reminder that S is for sine, which is opposite over hypotenuse. C is for cosine, adjacent over hypotenuse. And tan, T is for tan, opposite over adjacent. So for number 9, where sine is 4 over 5, the opposite side is 4, and the hypotenuse is 5. Because this is a special right triangle, I have memorized that this is a 3, 4, 5 right triangle. Yes, I could use Pythagorean to find that third side, but by memorizing this as a Pythagorean triple, a special right triangle with sides that are always the same, it'll save me a lot of time later. So once I have my triangle and my three sides, I'm able to do my cosine ratio, which is opposite over hypotenuse. Sorry, not opposite over hypotenuse, adjacent over hypotenuse, which means I'm going to use the other leg of the triangle, 3, and over the hypotenuse, 5. For tangent, it's opposite over adjacent. So opposite the angle where I'm standing, the little stick man, is 4, and the adjacent side is 3. So the tan ratio for that triangle would be 4 over 3. The next one I also have memorized is a, trying to get a different color, is I'm standing here, and it tells me that my cosine ratio is 5 over 13. So if I'm standing in this corner, adjacent would be here, and hypotenuse would be here. And again, because this is a Pythagorean triple, a special right triangle, I have memorized that the other side or leg is going to be 12. And you can do that by Pythagorean. Again, Pythagorean theorem will get you that third side, but I'm trying to save you time and save you trouble as you start to memorize things you need for the things like the unit circle. I can now do my sine ratio. Opposite over hypotenuse is 12 over 13. And then tan is opposite over adjacent, 12 over 5. The last triangle, I'm just going to move this down a little bit, is a special right triangle, but for this one, oops, I was trying to get a different color. Nope, it's not working very well. There we go. Nope, not getting a new color. Oh well. For number 11, special right triangle, I'm standing here. It tells me my tan ratio is 1. Well, it's a ratio, so it has to have a denominator. That's 1 over 1. And tan is opposite over adjacent, so 1 will be this leg and 1 will be this leg. I know because I've memorized this triangle that the third side is going to be square root of 2. How do I know that? Because when the legs are the same size, that means it's a 45, 45, 90 right triangle. And the sides are 1 and 1, and the hypotenuse is square root of 2. Now I'm able to do my ratios. Sine is opposite over hypotenuse, so it's going to be 1 over square root of 2. This is the rationalized answer, and we will practice rationalization, I think, below on this same page. And the answer for cosine is going to be the same. Since the legs opposite and adjacent are both 1, cosine is also going to be adjacent over hypotenuse, 1 over square root of 2. Now I'm going to expose the other answers, and I'm just going to talk about one other special right triangle. Here's 12, 13, and 14, and I want to focus on 12 and 14 because those refer to the same right triangle. Again, I'm standing here if I'm talking about 12, and it tells me sine is opposite over hypotenuse, or 1 over 2. I know because I've memorized this Pythagorean triple as well, that the third side is square root of 3. How do I know that? Because this special right triangle is a 30 degree, 60 degree, 90 degree right triangle, and the corresponding sides are 1 and the 90, the square root of 2, the corresponding side to the 90 degree angle is the square root of 2, and the side opposite 60 is 3. Once I know this, it's easy to do the other two ratios. And number 14, if you notice, they give you the tan ratio of square root of 3. Again, it must be a ratio, so it's over 1. As soon as I see that square root of 3, I go right back to this triangle again and my memorization of this special right triangle or Pythagorean triple. Below, I'm going to just expose the answers. Remember, anything divided by itself is 1. For number 2, you can do 8 square root of 3 over 5. You can use keep, change, flip. Division becomes multiplication. Do the reciprocal of 1 over 5 to become 5 over 1. 5 divided by 5 is 1, leaving only 8 square root of 3 as the answer. Below, I'm showing the answers for all of them, but I'm going to talk about number 5 and number 7 because the instructions say to rationalize. So that means I need to get rid of the square root of 2 in the denominator and make sure it goes to the numerator. So 1 over square root of 2 can be multiplied by 1. Any fraction can be multiplied by 1. I'm going to do square root of 2 over square root of 2 because square root of 2 times square root of 2 is 2. and 1 times the square root of 2 is square root of 2. So in rational form, it's going to be rad 2 over 2. And if you've memorized what we talked about above, that square root of 2 tells you I'm talking about a 1 square root of 2 right triangle, 45, 45, 90 degree right triangle. Number 7, I'm not sure which I'm dealing with yet because I need to rationalize. Rationalize means multiplying by 1. I'm going to do 1 in the form of square root of 8 over square root of 8. Square root of 8 times square root of 8 is 8. And then it becomes 4 times the square root of 8. 4 goes into 8 2 times, so it's the square root of 8 over 2, but the square root of 8 can be changed into the square root of 4 times 2 in the radical sign, and the square root of 4 is 2, so I've simplified this. And now with the 2 in the denominator, your final answer for number 7 is going to be just the square root of 2. Page 3 has a lot of information, but there's only a little bit that you need to know, except for memorizing that radian to degree conversion, as well as degree to radian conversion. So why do we use radians? Radians, first of all, are real numbers. They talk about arcs as basically proportions of our circle. So we can remember that our circle is 360 degrees, but we also know that the circumference is 2 pi. So 360 degrees equals 2 pi. These are both the same measurement of, or different measurements of the same circle. 2 pi has to do with the radian measurements or arcs. So you've got to think of each one of these arcs is a proportion of the 2 pi, and 360 is the way you've always measured angles so far. And I keep trying to change colors and I'm not having good luck. Now, when I'm doing my conversion, since 360 degrees is the same as 2 pi if I'm measuring radians, notice that I can reduce both sides of these equal signs by dividing by 2. So 180 degrees is the same as pi. So I'm going to use these measurements in order to convert my degrees to radians and radians to degrees. Remember from the previous page that we were converting or rationalizing radicals in the denominator by multiplying by 1. That's what I'm doing mostly in this page. I'm going to do 4 examples and then expose the rest of the answers, since this was another thing that you were supposed to do after your test on Friday. So I've got pi over 4, and I need to convert that to degrees. If something has pi in it, I already know it's in radians, and I need to get rid of the pi. So when I'm multiplying by 1, I'm going to multiply by 180 over pi. 180 and pi are the same measurement, and so since they are the same, I'm multiplying by 1. I can divide out the pi's to 1 when I multiply, and then 4 divided by, 180 divided by 4 is 45 degrees. Number 2, pi is in the measurement, pi over 3. That means I need to convert to degrees. Again, I'm multiplying by 180 over pi. When I do that, multiplying means that I can divide out the pi's, and the pi's divide to 1. And then 180 divided by 3 is 60 degrees. Final answer for number 2. If I want to show the answers for number 3 and 4 and 5, also this is going to be radians to degrees. So I'm multiplying each time in 3, 4, and 5 by 180 over pi. and reducing each of those gets me 30, 90, and 120 degrees. Remember, simplify, reduce to the lowest common, I shouldn't call it common denominator, just the lowest fraction you possibly can. For number 6, they're giving me an answer in degrees. I need to change that to radians. This means when I'm multiplying by 1 this time, I'm not multiplying by 180 over pi. I'm multiplying by pi over 180. That introduces pi into the angle measurement, and then I am reducing the fraction of 135 over 180. You need to find the largest number that divides into both of those. 45 is that number, so just like I can multiply every fraction by 1, I can divide every fraction by 1. So I'm dividing by 45 over 5. 135 divided by 45 is 3, and 180 divided by 45 is 4. I'm introducing pi into the problem. Final answer for number 6. 7 is also being multiplied by pi over 180. I need to reduce that 150 over 180 by dividing both the numerator and the denominator by 30. 150 divided by 30 is 5. 180 divided by 30 is 6. So introducing pi into the problem, it becomes 5 times pi over 6. Doing the last 3 problems are also going to be multiplied by pi over 180, and I'm going to get 8, 9, and 10, these measurements in radians. I'm going to stop this video here and start the next video on the next page.